you. To start off, I'd like to thank Summer Rupert and Josh Maurer. They've been working closely with me, and I value their help and input that they've had on this project. I'm going to be talking about the relationship of glaciers and the watershed in Bhutan. I'll first mention a little bit about the overview of climate change, the implications that it's having in this small country in the Himalaya. Talk about the methods and the difficulties that I encountered while doing my research. I'll talk about the glaciers that I was able to delineate and outline, and then the watersheds and the implications of what this country is going to see. First of all, I'm thankful that Josh was able to go in front of me and then give you a little bit of an introduction, so I can just jump right in. Global temperatures have been seen to be increasing at a rate of 1.2 degrees Celsius every decade since 1950. There's obvious long-term effects of rising temperatures globally. A study done in 2009 indicated a melting rate of glaciers is about 3 times the global average in the Bhutan than the rest of the world. There's an old Bhutanese saying that says, "Our real enemy is fire water. Nobody can defeat them. It's our fate and we have to live with it." In the image is a village in the Bhutan nestled up in the Himalaya. There was a flood that occurred in 1994, and as you can see, it was pretty significant, the damage that was done to this village. So as climate change is happening, there are being more and more studies done as to the results and consequences of this. One of them that happened, that's a very real threat in Bhutan, is glacial flooding. As you know, as the glacier comes down, it picks up a lot of rock and dirt and sediment and deposits them as the terminal moraine. These act as a levee or a natural dam that, as the glacial melts, it collects that meltwater into these lakes. You can see right here, this is the glacier whose lake was failed in 1994. It's called the Leggy Glacier, Leggy Show Glacier. The flood killed about 28 people, and doing some rough estimates of the volume of water, the glacial lake is about 2.5 kilometers long, about 0.7 kilometers wide, and from a 2010 study, they estimate it to be about 142 meters deep, which is an extremely large amount of water that flooded out and killed these people. This acted as a catalyst for the Bhutanese government to recognize the dangers and implications of climate change and to take action in order to mitigate some of these disasters that could happen. They did a study and designated 24 Bhutanese glaciers to be potential dangers to flooding, and took action to try and mitigate these disasters. One area of concern is 8 of the 24 glaciers reside in a single valley in the Bunaka-Wangdu Valley. This is the same valley where Thimphu, which is the capital of the Bhutan, resides. And so there's obvious economical, religious, social, and political consequences if there were to be a major flood incident. Pictured here is the Hanukkah Zong, or a Bhutanese temple. It's the second oldest temple in Bhutan. The king of the Bhutan actually designated it as the center of political activity. So, which, as you can see right here, sits right off the river, which would be affected by one of these floods. There's an old saying, an ounce of preparation is worth a pound of mitigation or relief. So there's obvious benefits that we can do to prepare for a disaster like this. My research, the goal of it was to identify hazardous areas, including the correlative glaciers from which one of these floods would originate. We found that the biggest threat is the Lake Thormi, which is right in that nestle of the 8 glaciers that are potentially dangerous. It's nearly filled to the brim, and they've estimated that the dam failure at this particular glacier would be about 3 times the size of the one that happened in 1994. So what I did was lineated the glaciers that we could see around the Bhutanese Himalaya, and used ArcGIS software, which is a photo imagery manipulation software, in order to calculate their watersheds. There's also implications as far as water availability in the long term. As Josh talked about, the glacial runoff from the Himalaya give water supply to China and India, which with their populations combined add to about 2 billion people, which is nearly a third of the world's population. So that is a lot of concern right here. In this population density map, you can see India and China are the darkest colored red, particularly right here in the northwest part of India, which is directly south of where the Bhutan. So you can see the direct correlation of what this would have to do with that population density. If we zoom in, we can see a little bit closer the darker area right here that I was talking about. This is the small country that's Bhutan. So as I mentioned before, I obtained satellite imagery in order to do the calculations and delineate the glaciers, including SOTM, DEM, and the ArcGIS base map which is provided. I outline the glaciers by hand using ArcGIS and imagery comparison, as sometimes it's difficult. And ArcGIS Toolbox, it's a model, an automatic method of using pixel values and the digital elevation model. They can articulate which would be the easiest flow path of water using the DEM, and then you can find out local and regional watersheds. The difficulties of the imagery include resolution problems. Sometimes with the older imagery, you'd have resolution anywhere from 30 to 90 meters, which regionally is acceptable, but as you zoom in closer to find the finite glacial boundaries, it becomes a little bit more complicated. Up-to-date imagery, cloud coverage, human error, and dirty glaciers. The Himalaya is particularly, not only is it remote and rugged, so there's not a lot of field data, it's also in a region that's affected by both large snow coverage in the winter, making choosing between glaciers and the surrounding area a little bit harder, as if they're all under blankets of snow and you can't really see the direct glacier. And then on the flip side of that, it's monsoon season during the summer, which the cloud coverage makes it a little bit more difficult. These are images that I had to deal with. As you can see right here, these two images are a little bit higher resolution, but even in the same imagery, this middle one had a lot less resolution, making it difficult to find the boundaries of the glacier. In this image, my glacier came right through in the middle of this cloud, so finding the tail and moraine, sometimes you have to use your best estimate. And then this is an example of dirty glacier, or a glacier that is covered with rocks. And as you can see, it's a little bit more clear up here, but as you get toward the bottom, you can be off anywhere from tens to hundreds of meters to where the toe of that glacier is. For the sake of simplicity, I boxed off the different areas of the glacier so that we can zoom through these. For brevity of time, I'll quickly go through so that you can see the lineation of the glaciers. And then watershed, so this is my water accumulation analysis from the ArcGIS. As I mentioned before, they can calculate what is going to be the easiest pathway of flow for the water. This is my area right here, and you can see kind of these white string river-like pathways. So this is the analysis that they put in, and then you add pour points, which are in essence giving it a direction of flow. So if you put one right here, it's going to say all of these rivers are flowing down this way. And then you throw this information into a black box system where you push run and it calculates the general watershed area. These are the different watersheds, starting from the smaller scale to larger. There's roughly 16 watersheds that I calculated on this order of magnitude. I used, for those of you familiar, I used about third or fourth order string systems, so not as small river strings, but generally larger rivers that are coming out of these areas. And then this is the larger scale. There's 4 coming through here. These ones are a little bit more elevation, and then you can see as they move through the Himalaya region. So the first area that I'd like to talk about is the flooding. The area of most concern is right here in the Punakha Valley. This is Thimphu, right in the middle, the capital of the Bhutan. So that's the area of largest concern. You can see the river, it's got both coming down through this gully and this gully right there, with a lot of glaciers to feed that water. We also have a large watershed right here, which has potential outbursts just because it's got a very large area. So there's also going to be a lot of glacier and snow runoff that's feeding into this area. The good thing is that since there's a larger area for this to dissipate through, though the risk of flood is greater, it's also going to be dissipated over a larger amount of area, so it won't be as severe. The government has received international funding in order to mitigate for these challenges, and they are taking active precautions. They are trying to manually control the water levels in these natural dams. Not only that, but they're installing sensors downstream from the dams along the rivers in order to give a warning to the villages that are in harm's way. The nearest villages, since it's a largely nomadic society, the nearest villages would only be saving them, a minute or two because they're literally living right outside of these dams. But Thimphu is about 7 hours water distance, so that would give them plenty of time to evacuate to a necessary elevation so that there would be minimal loss of life. Next is long-term water availability. As Josh mentioned, they recognize that the threat of losing a water source is a real consequence of global change, or climate change. And so for that, they've installed certain water storage facilities and hydroelectric power stations in order to try and lessen the water flux that's leaving the system and maximize their water efficiency.